Read on CG Talk. Thank you for your attention. Today is, or tonight, is the last and third part of my Krakatoa introduction. Krakatoa is a massively cool particle renderer for Cinema 4D, which will release next week on Monday. And it's already available for a couple of other products, so we are finally bringing it to Cinema 4D. In the last 2 days, I've been going to the basics and then a little bit more advanced things, and today I'm going to one of the more advanced uses of Cinema 4D Krakatoa, which is sticky camera mapping. Camera mapping you already know. You have your camera, you have some texture or animation that you can project on geometry in the scene. When you're using Krakatoa, you can project the same way images on particles. But you can think of the particles as image pixels, but in 3D space. So if you go to Nuke or any other application that's for compositing but has 3D space, basically you're manipulating things there in 3D, but you're producing 2D things. The same way with Krakatoa, you have the particles, and they can carry color information, but they can be sorted back to front and move around in 3D space and have their colors. So I can create really special effects with them, specifically taking a solid object, camera projecting a rendering or a real-world image of that object onto the particles, and then blowing the particles around while sticking the original color of the camera projection to the particles, which looks like it's dissipating. This example that I'm showing here is from the first public demonstration of Krakatoa in 2006. We went to SIGGRAPH at 2006 in Boston, and we showed this animation, which is basically a mini model from the Italian job Previs, Frantic Films, which ThinkBox software came from as R&D department, now a software company. Back then worked on the previs of the Italian job, and we had that mini around, and we basically rendered it in a ray tracer, reprojected an animated camera onto the particles and blew the particles around, but we actually stuck the color of the projection, which means if a particle is born at a certain point in space and moves around, it will still continue keeping the color that is being projected to its birthplace. For example, I was born in Bulgaria. I moved to Austria for 12 years. Then I moved to Winnipeg for 7.5 years. Then moved to Vancouver for the last 3 years. But I'm still Bulgarian. I was born, I know exactly where I was born. And if I had to get a camera projection, I would probably get the Bulgarian flag projected on me. So no matter where I move in the world, I still keep my original color. And the same trick we are doing here, and I'm going to show you how this can be done in Cinema 4D. In fact, we decided not to release Krakatoa for Cinema 4D unless we have easy tools to create this effect. Because we know how important it is for specifically for commercials. Lots of people want to do this. And we made it as easy as possible. It's actually, we have some features that are unique to Cinema 4D that are not in Max and Maya versions of Krakatoa. You can still do the same effect there, but with a lot of jumping through hoops. So, let's start with a simple example. I have a scene here, which is for camera mapping, and there is somewhere around here a bunny. I took the Stanford bunny, which everybody probably knows. And I used thinking particles in order to actually show you that it's possible to create this effect with pretty much any system that exists in Cinema 4D. So in my simple, very, very simple particle setup here, I'm emitting from a mesh of a bunny and sending the particles to one group. Then from that group, I'm actually using the deflector to just touch them without really deflecting them, just inform them that they were supposed to start doing something. This is exactly the effect that we did on the Mini. We just let the deflector pass through it and tell them now go. I'm pretty sure there are better ways to do this, but I'm pretty new with thinking particles in Cinema 4D, so that's what I could do. So whenever they get touched, I send them to group 2, and then that group 2 is actually affected by a wind. And the result I have already pre-cached to a PRT sequence, as I was explaining yesterday. Once you are happy with your simulation, you can actually go and save a PRT sequence where all your millions or hundreds of thousands of particles are moving around, are already saved to disk. Right now I'm loading only 1%, and I'm loading them with every end by ID. That means that when I'm moving the time slider, it will be a little bit slow. We already rendered to the standard renderer of Cinema 4D to a TIFF sequence. And I'm using that sequence for camera mapping. Here it is, actually. This is the bunny rendered with a moving around camera and saved to a TIFF sequence. And obviously, I'm using, in this material, I'm using camera mapping. And the only thing that I had to do in addition to everything else, actually two things that I had to do, I had to tell my particle system that is being emitted when it was being saved to disk to produce a special channel called BirthPosition. This is part of our Krakatoa TP source, and is actually part of every source that we have, X particle source and so on. They all have this checkbox. And when you start saving particles to disk, it starts remembering which particles were just born, figures out what the position was, and for the following frames, it keeps that value in a channel and never changes it. Even though the position might be changing, but position remains as I described it, where the particle was born. And once I save those particles with this birth channel, in my tag, Krakatoa texture tag, which is already assigned here, I have specified that whenever some texture, like a camera mapping, requires a position channel to figure out what to project exactly, instead of using the original position channel that is on the list, I can select the birth position instead. In fact, I can select any channel that I want. I can say custom channel and just type in the name. But I already have birth position hard-coded there because that's something that we really like to use a lot. And then the other thing that I have told it is to output, not to the color channel, which is the RGB typically, but to the emission channel, which in our case for the particles is the self-illumination. So when we start rendering this, we don't really want to do all the volumetric shading that I was talking about in the last 2 days, not even additive rendering. We actually have enabled the checkbox that says ignore whatever lights are in the scene. And we have checked the option that says use the emission. So we are rendering volumetric particles. That means they will be drawn back to front. They'll overwrite each other with the latest color that they have, which is the camera mapping. And they will be self-illuminated, so they will be actually painting that color onto the image. And here is the result. I have already rendered it, not to waste time. We can go to the camera mapping and look at the output folder, and I have this rendering, which is not exciting, but what you're seeing here is the result of the rendering of the standard Cinema 4D renderer projected onto Krakatoa particles. Then I play it back, and you're going to see that the particles start moving and the colors are sticking, so you have something that turns into poof into a cloud. You can go, of course, with much better texturing on the original rendering. You can do pretty much anything, or you can take a plate that was live footage, project it onto just a stand-in geometry, render that one, or take directly the footage and put it in the camera mapping, and then let the particles flow. And yesterday evening, I actually showed you an example from a real production that did exactly this, which was the Twilight apparition. We have Bella underwater, trying to kill herself. The apparition of Edward appears, and she waves with her arm, and the fluid simulation distorts the particles, and that's what you get. So this exact effect, you can create an X particle system. For example, check the birth position channel, create the shape of Edward there, project the plate that you got from production, create lots of particles, camera projects onto those particles that plate with the birth channel instead of the position channel, the birth position channel instead of the regular position channel, simulate those particles with some curl noise, and you have a beautiful dissolving object that turns into dust. So this is kind of powerful, and in fact we have used it in another case where we had a show called Sucker Punch. That was something that Zack Snyder directed, and of course it was full of slow motion and a single camera move for 2.5 minutes or something like that of girls cutting robots on a train. And the trouble with this one was that when the show was done, the actual girls, the actors, were holding a real sword, playing against green clouded people, and they would have to stop with the sword at the moment where they would cut a robot, and then we had to replace the girl, the sword, and the robot with digi-doubles. Trouble was that we also had to render the hair to look just like the real girls. I'm going to play you that a portion of it. This was done at Prime Focus. It's one of the last projects that I worked on before I moved to ThinkBox Software. But as I mentioned, Krakatoa was at that point kind of an in-house product still and in transition to ThinkBox software. So we actually sat down and said, we're going to render the hair with Krakatoa. Everything else might be V-Ray, but for the hair, we actually have a big benefit to do this. And I'll explain what the benefit is in a second. Here is a little bit of that sequence where whenever the robot is being cut, the girl is digital. Whenever she's not cutting, she's real. So she cuts, digital, still digital. Then when she finishes, goes back to the real girl. That one is digital at this point. Then she cuts the next robot, and I'll show you the making of, and we will see the green screen and how that was done. So the tricky part, as I mentioned, was this girl, the hair, we modeled the hair exactly as it was on the last frame of the live plate. Then we created the digidouble there, set it, posted it, combed the hair, and dynamically simulated it what would happen when she moves around. But the trouble is that you have in Krakatoa, in fact, we have a hair shader that I showed yesterday, the marginal one, but no matter how much you tweak it, you're not going to get the real hair from the set. So how do you do a good transition in Nuke where there is no pop? And what we did was we generated the hair on the frame where the reference was, where it was combed, generated all those particles, then moved to the frame that we had to render, generated new particles with the same count along the same hairs, and took the position from the one as the reference, the birth position, for the other one, and camera projected the shot, the plate of the static girl on the last frame onto the moving hair. That gave us a couple of frames of real color to slowly blend into the CG shader. And here is the making of this, where you can see it. Come on, girl. So here is the digidouble with the Krakatoa here. Everything is CG at this point. And then she finishes cutting. And at this point she's real, and we pull away all the CG until green screen. So basically exactly the same approach of taking camera mapping, creating a reference frame, going to a different frame, projecting onto particles, rendering the particles as if they were hair, and getting exactly the colors that you want for as long as you want them. Was applied here, just like on the Twilight shot. And in fact, there was a shot in Tooth Fairy where there was a hockey rink that had to dissolve into a kind of vortex going up to the fairyland, and we just camera projected onto the model of the rink. We put particles on it, camera projected the actual plate, and then swirled it around, and it created a hole, and the whole thing swooped into it. So a lot of production cases where this is really, really useful approach to do something that is producing the tricky effect of turning something into moving cloud of points, or even just distorting it if you want. So when you're doing exactly the same effect, but with external data that actually doesn't have a birth position channel, or any birth channel for that matter, you have a problem suddenly. And I showed also on the first day in the end, one of these examples where we have a logo reveal with the Cinema 4D logo, which after it plays back, it reveals the Krakatoa logo underneath, and the colors are sticking as we said. But this, what you're seeing here, is not the Cinema 4D X Particles or Thinking Particle system, it's a real flow system. So how do you do exactly the same effect with external particles that are coming from bin files from RealFlow? And this is the other problem that we had to solve on the Cinema 4D side. In addition to adding the checkbox that creates birth position, which is easy when you have access to the actual systems inside of Cinema 4D, we had to develop a tool that allows you to do exactly the same approach with completely external particles. Even a LiDAR scan. They give you something and say, okay, this was scanned, it's the same point cloud or whatever, but it's over time changing. I don't know. I don't think that will happen ever because the count won't match. But in RealFlow, we actually have the scene here. And this was created by Daniel from Ugly Kids, who actually started the whole Krakatoa project that we then joined, and thanks to him, we are getting this product released, pretty much. So here is a scene which I have prepared. which shows you we have 3 loaders in the scene. Actually, there were 3 simulations performed. And if we look at the particle file, currently I'm loading PRT files, which have some extension BP, which means they already contain the birth position channel. But in the same folder here, you can see bin files which don't have any BP in them. Those are the original RealFlow version like bitmap 15, bitmap 16, and bitmap 17 files. And there are subfolders where I actually saved the reprocessed ones with those channels. How did we do the reprocessing? If you open the dialog, the render dialog with Krakatoa there is an additional tab called Tools. And if you go into Tools, you'll see this is my external drive's letter on Windows, E, which was pointing at the location of one of those bin sequences. I had picked that one, and then I picked another location with subfolder called BP that contained this PRT sequence that I'm currently loading. You just pick one existing sequence that doesn't have any birth channels in it. You tell it a new output name where you want to go, and then you select which channel you want to stick forever at birth. At this point, we say we want the position to be written to a channel called BirthPosition. That means we start loading those files, look at the ID channel, and detect each particle that is newly born will be a new ID that we haven't seen before. We take its position, remember it, and start writing in each following frame for that ID. So we end up with a new sequence which has a BirthPosition channel. Now, if that sequence also had a color channel at birth that is changing to some gradient over time, I could go and say, I want to read the color, and I'm going to create a new custom channel called BirthColor, and do another iteration. So load what I just saved with the BirthPosition in the first slot, create a new one that is BP, CP probably, or something. No, actually BC, for BirthColor. Run it again, and I can run it as often as I want, reprocessing and adding additional channels that is sticky for that particle through the whole life with the original value at birth time. It might be useful. You might need that color at birth in order to blend it with something else later or something. Then you hit that button, it processes in a minute or whatever it takes to save all those files again, and you have suddenly the data that you need out of an external source that never had that data. And of course, if we would go and render one of those frames on any of those frames, hopefully it will render exactly what we expect. At this point, what is rendering is a relatively high resolution. And you notice that the distance between the particles is really large. This is the original particle system as it came from RealFlow. And the RealFlow simulation didn't contain that many particles. It's less than 100,000 as far as I remember. Actually, we can go and take a look at the script console, and it says 142,000 particles were loaded. That's just not enough. So we have, additionally, as I showed yesterday, we have a repopulate tag, and of course, I'm not holding the right key here. I never know which key to hold, but I selected all 3 repopulates, and I'll just enable them. So now all the 3 particle systems will be actually loading and creating new particles on the fly. Let's hit render again. This, of course, will take a little bit longer because it has to take each one of the 3, the first, the second, and the third, seed new particles around. And when it's done, we're now at 78% here. It's going to also process the camera mapping, and each new particle that is generated has the same birth position information from its source particle that actually spawned it. So all the colors will be kind of there, exactly as they should be. This is creating a lot of particles, so we are already at about 30 seconds, but there will be a few million particles that have to be created and camera mapped. Camera mapping 140,000 particles is really fast, but you have to keep in mind that evaluating a texture is generally a slow process. So the more particles you have to map, texture map in general, in Cinema 4D or in Maya or in Max or whatever application is using Krakatoa, evaluating textures is relatively tricky. We created 3.5 million particles, allocated 120 megs of memory, and we did some motion blur on the whole thing, and it got a little bit more dense than it was before. You can see this is the old one, this is the new one. It's much better. In fact, if I was rendering at a lower resolution, and I have one that I already rendered at very small resolution, here I didn't even have to do a repopulation. This is pretty much almost the RealFlow simulation. I think I did some repopulation, but it didn't require that much time. It was rendering much faster, because the smaller the resolution is, the less particle you need to fill all the pixels that you have. In addition, in order to get rid of the blue from the original logo, the actual projected texture is actually a move file that blends from the Cinema 4D logo over time into white. So here you still see the blue colors, and then after a while they start fading out and it goes into white. But that's a relatively simple trick with just the camera mapping. So hopefully this gives you some ideas of how you can use this tool set that we specifically worked on to make the easiest thing really to use of all implementations of Krakatoa within Cinema 4D. And because I have 10 minutes left and I already showed you the basics of how to do the camera mapping, I'm going to show you something that I haven't talked about yet in the last 2 days. I pretty much run out of time the other 2 days, and today I have the time. In the plugin Krakatoa area, there is one object that I haven't spoken a word about, and that's the fractal one. If I click it, it creates a number of particles on the fly. Right now it creates 100,000 in the viewport and 1 million at render time. I can create 1 million in the viewport, doesn't really matter. It gets a little bit more dense. I didn't want to clone it really. And you can move around it in 3D, and you see it's a 3D cloud. It has currently a gradient of only 2 colors, but I can enable this gradient and create my own colors here with using the typical Cinema 4D gradients and make it look even more beautiful. And the color is actually generated based on the distribution, the fractal distribution of the particles in space. And the actual distribution right now is being controlled by all these parameters here, and each one of these parameters can be tweaked by hand in order to change the shape, and it can be keyframed over time. And these values were generated randomly using one single random seed that produces always this design. When I click the button Create Fractal Design with 4545, I always get that look on an Apple. On a Macintosh, on a Windows machine, looks a little bit different, but it's still always the same on all Windows machines. In fact, in Maya, you're going to get the same design with the same number. But, so if I go here and enter another number, some number, let's say 20, that I don't like this design, I'll try the number 9. That looks more interesting. Okay, I go to frame 0 and hit the keyframe all layers and set keys to all those parameters that we have. I can go now to frame 90, and I can say, okay, I want to reset this one back to my initial design. Say, create that design, keyframe that one, and now I have, hopefully, did I? I think I didn't. So they are keyframed, right? So I have now 1 million particles being morphed from one design to another, and at any point when I like the look that I'm getting intermediate result, like let's say for whatever reason you like this shape, you can go and say keyframe all the layers at this frame. Then I could go to the first frame and remove the keys from that frame, go to the last one and remove the keys from that frame. And now I have a design that has on all frames exactly the shape of that intermediate blend. And I can go with another design and start blending and do genetic morphing until I like the result. Then I can go and do a ring array or linear array or whatever of all these objects and render them in Krakatoa, and you can get 100 million particles of nicely distributed, strange shapes that are changing over time. It's a little bit of a make art button. It's not really necessary for production, but we felt it's good to have a very quick way to create an interestingly looking cloud of 1 million particles without having anything, not even a mesh. You just open it. We've been testing with this a lot. We just create it and hit render, and almost immediately you get what you need. Obviously, I would have to go and set Krakatoa to the renderer as the renderer and probably do additive mode and so on. But in general, it's a tool that you could, especially in the world of Cinema 4D for commercials and background, beautiful logos and psychedelic stuff, pretty much, might come useful. It actually uses a bunch of transform matrices in order to define how those particles are moving, and you can have a different number of layers that control what will happen. For example, if I go to only 2 layers and create the default design again, it will look completely different than with 3 layers. If I go to 3 layers and say exactly the same design, it adds more detail to it. If I go to 4 layers and create the same design, it actually goes through another transformation and it looks completely different. And each one of those layers here has the last parameter is weight. And if you set this weight to 0, it disables that layer completely. So you can go and say, I'm going to turn off things. You cannot draw any design with less than 2 layers. You really need at least those 2. But this is kind of looking interesting already. And you can keyframe those blends to slowly fade in and out, and just like with all the other parameters. If you want something to start as a certain design and then slowly dial that in, that would happen. And it will deform and change and so on. It also has a bunch of channels that you can save it to PRTs and load it, and you can see even what channels are there really. And those channels, you can list them here in any tag that deals with channels. You can see that you have position, color scalar. This is the value that defines which of the colors from the gradient to actually pick. There is a random value that was used for each particle. It's actually generated if you ever need to know a specific unique number for that particle in order to do crazy stuff in the future. When we give you a node-based editor to deal with the channels, this will be very useful to have. But in general, it's there. That's the color that was generated, and there is the same value is also written to the emission channel. In case you want to render emissively immediately, you don't even have to set it. It's already there. And because I have 5 minutes more, now to something else that I forgot to mention last time. If you're, let me open quickly from day one the first scene. Let's say we can do the bunny, we can do the Buddha. Doesn't really matter. But where is it my Buddha? And why is it not showing? See if we can get any other mesh here. Nope. Okay, let me create quickly the simplest thing there is. I'll create a figure, and I'll create a PRT volume out of it. Krakatoa, PRT volume. And I'm going to hide the mesh in the viewport. So we have now the figure. We can increase the resolution a little bit so we get more particles. The one thing that I forgot to mention the other day is there is an enable shell option, which you can check. And you can define the band of particles that will be created around the surface. And you also have a shell start option, which tells you where the actual volume starts. So you can keyframe both. If you keyframe this one, you can solidify an object or make it from volume to a surface. If you keep this one big, but you start changing this one, you're going to shrink it to 0. It's basically just matching in the level set and measuring the distance to the surface and creating only particles if they are at a certain distance. So this is another thing that where I can do revealing effects. If you want something to come out of nothing, you can just take a mesh, fill it with particles, keyframe that parameter, and you get something that slowly shows up. And of course, then you can render it normally as it was. And I think I'll stop at this point because the one thing that I want to announce, I had 90 minutes here. I had lots of fun, but I haven't even scratched the surface of what is possible with this tool. So we decided right after we shipped the product on the 14th, a week later on 23rd, I think it's 23rd and 24th, Wednesday and Thursday, we'll have an online webinar in 2 different time zones. So the one will be mostly for Europe, United Kingdom, people that are currently sleeping, and the other one will be for North America, and we'll go over as much as possible technical details, overview of what each property does, each attribute that's there, and all the checkboxes and all the sliders, and why they're then what they do. Because here it was more about giving you a taste, showing you some examples from production, and giving you an understanding why you need this. But once you start using it, and we'll start selling licenses, you can have 15-day evaluation versions, license that you can run to figure out if you like it. You will need more examples. I'll start writing more and publishing more tutorials in the next days, but we want to have a live webinar where people can also ask questions and go through the whole system and in as much time as we can have in a GoToMeeting or GoToWebinar session. So mark 23rd and 24th of April as another set of presentations from ThinkBox Software about Krakatoa for Cinema 4D. You are very excited about this product. Hopefully you're also excited. And if you have any questions right now, you can ask me. And if you don't, you can talk to me on the site. And yeah, I started 2 minutes earlier, and now I'm almost 1 minute ahead of time, but I think that's good. I'll play some video of something just to... Okay, this is This is the grandfather of Krakatoa. This is the point renderer from 2005 that later gave birth to Krakatoa. It's still very similar, volumetric, and very glowy. It's from the movie Stay, featuring Ryan Gosling and Ewan McGregor, which nobody has ever seen because it lacked promotion. But it's a Mark Foster movie that was supposed to be a David Fincher movie, so the content is kind of interesting and visually very interesting transitions, and it drove us mad working on that one because we had notes that we had to decipher, and we have a T-shirt with the actual notes about the jellyfish turning into the elephant on the frame, whatever. And so if you can find that movie, watch it. It might be interesting for you. It's kind of a not really thriller, but it's slightly psychological thing. And it ends with this beautiful sequence on the Brooklyn Bridge with about 500 million particles per frame rendered in 2005 on 32-bit machines, in multiple layers, of course. So actually 2004 was the rendering. The movie came 2005, but that was one of the first projects I worked on at Frantic Films. So it gave birth to the whole particle thing. I'm done. Thanks for the attention,
guys.
and thanks everybody on the internet.
Yep. And we'll be back tomorrow morning at 9:30 a.m. with Kevin Aguirre from Cake Studios. And let's give Bobo another big round of applause. And of course, we'll be around tomorrow. If there's other questions at the demo stations, you can feel free. You'll be around tomorrow, yeah? Nope, just kidding. Bobo's leaving. So check out his tutorials online.